Today we're talking about parallel and perpendicular lines. Now you'll recall that a parallel lines are a set of two lines that never cross. A good example of parallel lines is right in the word parallel itself. There are the lines. Right there, they never cross, they can go on forever and ever, and they will never touch. Mathematically, what that means is they have the same slope. Meaning, if I wanted to find a parallel line to the line y equals -1/2 x plus 4, which you'll notice is in slope-intercept form, that goes through, say, the point 3, 4, we can simply keep the same slope and then change everything else about it. Now we have the slope and a point, so therefore we should use point-slope form to figure out the rest of this equation. You'll recall that point-slope form is y minus y1 is equal to m x minus x1, where x1 and y1 are any point on the line. So therefore, we can simply plug in our information. Y minus a blank is equal to -1/2, our slope, x minus a blank. We then fill in the blanks. In this case, our y value is 4, and our x value is 3. Then from here, we could go ahead and simplify that into slope-intercept form. However, I'm okay if you leave it just like this. The reason being, I know that you could simplify this. You would distribute and then add 4 to both sides, which I just think is one more step than necessary. Also, we know how to graph from when it's like this as well. So I think we're good. Now, a perpendicular has a set of two lines that cross at right angles. Right angles look something like this or like this. The most important thing is that they cross at 90 degrees. 90-degree angles. Now here's the most important nugget of information based on what we're doing today. Oops, I want this tool. The slopes of perpendicular lines are what is called opposite reciprocals. Meaning, you have to flip the sign and you also have to flip the fraction. So using the same example we used earlier, if we had our line y equals -1/2 x plus 4, and we wanted to find a line perpendicular to it, the slope of that line would be -1/2, flipped the sign, which we'd take the negative and make it positive, and we would also flip the fraction, making the denominator the numerator, and you'd make it positive. So therefore, the slope of the perpendicular line would be 2/1. A few more examples. If we had something that was, say, -1/3, and we needed to make it positive, you would simply flip the fraction, 3/1, and make it positive. If we had, say, just +4, we would have to flip the fraction, 1/4, and then make this negative because we started out positive. Now, if we were tasked to find a perpendicular line that goes through a certain point, say, for example, the point 2, 4, through the line 1/3 x minus 1, we have all the information we need. First things first, we would have to take the opposite reciprocal of our slope. So in this case, 1/3 would become -3/1. Simply change the sign and flipped the fraction. And then we could plug it into point slope form. Y minus 4, simply pull the 4 from there, is equal to -3/1 x minus 2. And we could pull the 2 from there. Once again, I trust that you could potentially take this and rewrite it to make it slope-intercept form. I think it's one step too far. You don't need to. However, just for demonstration purposes, I will show you how you would do that. We distribute out the -3, so this would become -3x plus 6. Oops. One stroke too many. We would then add over the 4, giving us y is equal to -3x plus 10. As always, let me know if you have additional questions.